What's up? It's Ryan. Today we're going to be going over a little bit of logarithms. We've been working with exponentials a lot thus far, and so we've gotten pretty comfortable with those. And so what we're going to do now is explore logarithms, which are basically exponentials but in sort of reverse form. And it's very important we become fluent in both forms, although they basically accomplish the same objective, because when we get into advanced math, when we go to calc, teachers are going to expect you to know your exponent rules and logarithm rules like that. And so we really want to nail this down. Exponent rules and logarithm rules are one of the most important things you'll learn from Algebra 2, in my opinion, because they're going to be super applicable as you go later in math. So let's get straight into it. So logarithms are going to be in the form of log base b of a equals x. So basically what this is saying is b to the x power equals a. We read that out loud as log base b of a equals x. And so for me, exponentials work better in my mind. So I can work with logarithms, but almost every single time I see a logarithm, I immediately shift it to exponential form in my head. So it's basically about finding which one works best for you. If you can find the logarithm without even thinking about the exponential, hey, that's great. You do what's best for you. Okay, so let's go from logarithms to exponentials. Well, we want to find our b value. Our b value is our subscript. In this case, it's 3. So 3 to our x value, right, which is 2, equals our a value, which is 9. And that makes sense. 3 squared equals 9. What about here? Our b value, our subscript, is 7. Our x value, what this logarithm is equal to, is 0. And our a value is 1. That makes sense. Anything to the 0th power is 1. Okay, what about this? This looks a little bit more complicated. Well, what's our b value? Our subscript is 4. What's our x value? -2. What's our a value? 1/16. And does this make sense? Yeah, 4 to the -2nd power does equal 1/16, because when we have that negative exponent, we're basically flipping it. We're putting it under 1. So we have 1 over 4 squared. That equates to 1 over 16. That makes sense. Okay, what about here? We have 9, which is our b value, our subscript, to the x power. In this case, it's 3/2, equals our a value, which is 27. Does that make sense? Yeah, because we can basically split this up into 2 separate steps. 9 to the 1/2 power, or we can translate this to radical form, but I'm just going to leave it how it is. 9 to the 1/2 power is 3, right? 9, the square root of 9 is 3. Then 3 cubed is going to be 27. That makes sense. Okay, what about here? Well, we want to take our base. First of all, what's our base? Our b value. It's 14, so we're going to say log base 14 of what number? What's our a value? Whatever this is equal to. 196. Oops, I'm sorry about that. Log base 14 of 196 equals our exponent, which is 2. That makes sense. Okay, let's move on to here. Log. What's our b value here? Well, it's our base, 2. And then what's our a value? Well, our a value is just going to be 1/8, right? 1/8 is here, a value. That's going to be equal to, and sometimes actually it might be helpful to just put this in parentheses just so people know. Log base 2 of 1/8 equals -3, right? This is our x value. This is what we're raising 2 to, and this is what our logarithm is equal to. Okay, here, just some more practice. Log base, what's our b value? Well, it's our base of our exponent, which is 8, of 16, what our logarithm is equal to, equals 4/8, or sorry, 4/3, my bad. Here, same deal, we do log base, our b value, our base of our exponent, 12, of 1, our a value, equals 0. And one tip, whenever we see a log of 1 here, it's always going to be equal to 0, right? We see that up here with log base 7 of 1. We see it here with log base 12 of 1. Doesn't matter if it's log base 4 of 1 or log base 4,000 of 1. It's just going to be 0. Because anything to the 0th power is 1, right? Okay, so common log, when you don't see a base here, when you don't see a subscript here, when it's just written out, log of x, that means there's like an invisible 10 here. You know, it's base 10. And so that's something you want to know. Eventually we might get into ln, the natural log, which that base would be e. But yeah, this is something important to know. If you don't see a base here, it's just base 10. Okay, so now we're going to start evaluating logs. Here, I just go straight to exponents. This is how my mind works. So I think 4 to what power x equals 64. Well, 4 squared is 16. What about 4 to the third? 4 to the third is 4 times 4 times 4, which is 16 times 4, which does equal 64. So x is going to be equal to 3. So I'm going to say this equals 3. And what about here? Well, here we don't have a subscript. So what do? Well, we just assume 10. So we're saying 10 to what power? Sorry, to what power equals 1 over 1,000. In this case, what I'm going to do is, at first, I'm just going to ignore the fact that it's a fraction. I'm just going to say 10 to what power equals 1,000. Well, since we have 3 zeros, that's going to be 3, right? 3. Because, 10 squared is 100, that's 2 zeros. 10 cubed is 1,000, that's 3 zeros. But since this is a fraction, this is going to be negative, because we're saying 10 to the negative third. Sorry, that was what I was doing there. 10 to the negative third is just going to be 1 over 10 to the third, right? And that's where we get 1 over 1,000. So this is going to equal -3. Okay, what about here? And we have log base x of 343 equals 3. So we're saying x to the third power, right? This is just translating here to here. X to the third power equals 343. Now, some of you may know this straight off the top of your head. You may know your cubes. But in case you don't, what I would urge you to think of is think of numbers you know. So I would plug in 5, right? 5 cubed is relatively simple, right? It's going to be 125, and 343 is greater than 125, so I know it's going to be greater. And then what about 6? Well, 6 times 6 is 36. And then when we multiply by 6 again, we can do it out and we can get 216. But one helpful tip I would use in just all of math and using estimates, when we have 6 times 6, we're always going to end up with a 6 in the ones place. So no matter what we raise 6 to, we're always going to have a 6 in the ones place. Here, it does not have a 6. So let's plug in 7. Well, 7 squared is 9, right? Or sorry, 49. I was thinking in ones, my bad. So 49 times 7. Well, we can just think of the ones. We do 9 times 7. And 9 times 7 is going to be 63, right? So that's ending in a 3. You do it out, eventually you'll see that 7 to the third equals 343. So x equals 7. My bad, this is true. Yeah, that's a tip I would definitely use. Look at the ones place. That can help you, gauge what things are going to be what in basic calculations without doing everything out. Okay, here we have 27 to the x power equals 1/3. Well, I see this, and I'm going to ignore the fraction just like we did up here with number 2. I'm going to say, how do I get from 27 to 3? Well, 27, right? I think when we think about it, we have 3 cubed equals 27. So if we have 3 cubed equals 27, if we take the cube root of both sides, right? This is kind of messy. We'll eventually get 3 equals the cube root of 27. So here I can say 27. Instead of cube root, I'm going to say 1/3. The 1/3 power equals 3, right? But now, since this is a fraction, since it's 1/3 instead of 3, I would have to make this negative. So I would have to say 27 to the negative 1/3 power equals 1/3. That's how I get this equals negative 1/3. Okay. So a lot of this, for me, I like exponents more. I'm more comfortable with it, so I just do it this way. As you get more reps and reps, eventually this will be light. You'll see numbers like 343 and you'll know, hey, 7 to the third is 343. And you'll start to recognize patterns and see, oh, I look at 27, I immediately think of 3 and 3 to the third. And you'll start to recognize numbers as you become more familiar with them. Oh, my bad. I'm so sorry about that. Jeez, just disregard that. Sorry. Okay. Yeah. Okay, let's move on. Sorry. Oof. Okay. Here we have 1/4. Sorry. Let me. All my settings are different now. Okay. Just bear with me. Okay. Boom. Okay. Here we have 1/4 to the x power equals 16. Well, we could sort of think about this in the same, okay, sorry. How do I even do this? Okay, we could sort of think about this in the same light, right? How do I go from 4 to 16? Well, 4 squared is 16, right? 4 squared is 16. So 1/4 squared is going to be, right, all of that squared. We're going to square the numerator and the denominator. We end up getting 1/16. Well, what if I want to flip this, right? I want to flip these. So we do that by having a negative exponent. So we'd want to have 1/4 to the -2. That would give us positive 16. Okay. Here for 6, we have 27 to the x power equals 81. So I see 27, or first, actually, let's start with 81, because 81, I think we may be more familiar with. 81 is 9 squared, right? And 9 is actually 3 squared. So we could, maybe this has something to do with 9s or 3s, right? And now let's look at 27. Well, 9 is a factor of 27, right? 9 times 3. And because 9 is a factor, so is 3. And it comes out to be 3 to the 3rd power equals 27. So we see this, commonalities. We see all these 3's. So I'm thinking this has something to do with 3. So how about I get 27 down to 3, and then I build it back up to 81, if that makes sense. So if I get it down to, what I mean by getting 27 down to 3 would be what we did up here. If you see this, we have 27 to the 1/3 power equals 3. Now I want to go from 3 to 81. Well, I know 9 squared equals 81. I also know 3 squared equals 9. Well, why don't I just plug this 3 squared in for that 9? So I say 3 squared equals 81. If we remember our exponent rules, we know that we have 2 times 2. So this is 3 to the 4th equals 81. So we have 27 to the 1/3 power equals 3. And then 3 to the 4th equals 81. So what we can sort of do here is we can multiply these two numbers. So I'm looking at this number, I'm looking at this number. We can put 4 over 3 if we remember our exponent rules, right? So this is going to be equal to 4/3. Okay, let's move on here. Here we have 243 to the x power equals 27. Now, I'm actually going to erase some of this, if that's fine. You can just rewind if you need to look at it. And so here, I see something similar. I see this 27. When I see 27, I'm immediately thinking about 3. So now, since I'm thinking about 3, I'm seeing, hey, how can 3 relate to 243? And so how we do that, well, I know 3 squared is 9, right? 9 squared is 81. Once I get to 81, how can 81 relate to 243? Well, 81 times 3 is 243. Sort of thinking about it, hey, seeing this 27, 243 may look totally unfamiliar to you. You're like, hey, I've never seen that. I don't know 3 to the 5th power is this or whatever. But if you see that 27 and then you start thinking in threes and then you see, hey, how can 3 relate? Then you can eventually find that out and derive that. So let's look at this. Let's try to break what we want to do is we want to break 243 down into 3 so that we can then bring it back up to 27. So how do we break 243 down into 3? Well, here we know that 3 to the 4th is 81. I'm just going to borrow that. 3 to the 4th is 81. And now, how do I go from 81 to 243? Well, I know how I would guesstimate is I'd say, hey, 80 times 3 is 240. That's pretty darn close. 81 times 3 is actually 243 on the dot. So it would make sense that if I multiply both sides by 3, this basically has an invisible 1. We add those exponents, it becomes 3 to the 5th equals 243. Same thing how we did before by, taking the cube root, I believe, for both sides. Here we can sort of flip it around. We can take the 5th root of both sides. Another way you could think about it is raising it to the 1/5 power. When you raise something to the 1/5 power, that will eventually cancel out this 5 because you just multiply those exponents again. 5 times 1/5 is just going to be 1. We have 3 to the 1st, and then 243 to the 1/5. But here we're just using radicals. Anyways, these cancel out. The same thing, right? We end up getting 3 equals the 5th root of 243. Now, we just broke 243 down into 3. Now, how do we build 3 back into 27? Well, we do 3 to the 3rd power is 27. So what I'm going to do here is I'm going to write, when I think about this in my head, if I'm just doing this by myself, I would, leave that space open and then I'd put it over 5 because this, when we take the cube root of something, the 5th root of something, that means that 5 is going to go in our denominator of our exponent. And this 3, since we're raising it to that power, is going to go in the numerator. So it's going to be 3 over 5, meaning this logarithm is equal to 3/5. Sorry, that was kind of bad, but hopefully you can see the process. Okay, here we have 1/8. I'm just going to write it in parentheses just to make sure. To some power x equals 4. Well, some way I think about this is, first of all, I have this 8. I want to make 8 into 4. So maybe how I do that is they both sort of originate at 2, right? 2 squared equals 4. 2 to the 3rd equals 8. So this is somewhat basic, where you can see, hey, these numbers may feel familiar to you, which is good. Then you can recognize that. Eventually, the more and more you work with this, you'll feel familiar with a lot more numbers. But here we're starting at 8. Let's start at 1/8 and try to go to 1/2 actually. So 1/8 to what power? Well, we want to break this down into 2. And so the way we do that, we want this eventually equal to 1/2. Well, we're actually going to, or actually, well, to break it down into 1/2, basically what we're going to have to do is we're going to have to take the cube root of this, right? Raise it to the 1/3 power. Because if you think about it like this, by raising this to the 1/3 power, I don't know if this makes sense, but we're saying 1 to the 1/3 power. Oh Lord, that is horrible. Yeah, that's horrible. I'm sorry. Okay, 1/3, 1 to the 1/3, into 8 to the 1/3. 8 to the 1/3 is just the same as cube root of 8, which we know to be 2, and 1 to any power is going to be 1. So that's how we get to 1/2. Now, how do we go from 1/2 to 4? Well, what if I just do, you know what, let's just raise it. Let's take it in steps. Let's raise this to negative first power. I hope you'd agree with me in saying, hey, we have 2 now. 2 squared is going to equal 4. So we have these numbers. We have this 2, we have this -1, then we have this 1/3. So I'm just going to actually multiply all those and end up getting x equals -2/3. So this logarithm is equal to -2/3. Now, this is a complicated topic, and some of these, they can get tricky, and I know I sort of went about this in like a weird way, and part of it may be like a little iffy, going from 1/8 to 1/2 and recognizing, hey, we have to take the cube root of that. But what I do, maybe if you're completely confused, start with 8, right? Go from 8 to 4, and then going from 8 to 4, right, we take the cube root of 8, we get to 2. That's 8 to the 1/3 power equals 2. Then 2 squared equals 4. So that's where we get our 2/3. I'm just going to add that negative sign out front because we're not going from 8 to 4. We're going from 1/8 to 4. Hopefully that makes sense. If it doesn't, you can just come see me, email me, get in touch with me or Mr. Whitaker in some way, or Miss Lupien if you have her. Okay. Well, oh, Lord, this happened again. I don't know what's happening. I'm sorry. Jeez. Okay. So now let's work on properties of logarithms. Right. So one important property we want to know is the product property. And basically what this is saying is whenever we're adding logarithms of the same base, right, we don't have a coefficient or anything. When we're adding those, we can just multiply whatever we have on the inside. This is important. Now, logically, the opposite, if we're subtracting, well, what's the opposite of multiplying these? Well, we're going to divide. So that explains our quotient property. Now, actually, sorry, let's, look at these examples real quick. We have log base 4 of 3 plus log base 4 of x. Because they both have the same base, we can just multiply this 3 and this x and make that into log base 4 of 3x. And you can break it down, you can do whatever way you want. Here, we have log base 2 of x plus 1. We have subtract log base 2 of 5. So since we're subtracting, we would do division, right? We have the same base, by the way, just to make sure. We do x plus 1 over 5. And that's where we get that. Now, the power rule is something where, sometimes initially it may not seem so obvious. you may not initially notice it, but as you work more with logarithms, eventually you'll become super comfortable with it. And basically what it's saying is whenever we have an exponent in this inside part, when we're raising m to some power n, we can put it outside. So here in this example, we have log base 3 of 2x plus 1 to the third power. And now what we're just doing is we're moving that 3 out front to be a coefficient of this logarithm. Okay. Jeez. Yeah, I don't know what's happening. Okay. Now, yeah, just as a side note, natural logs, same thing. When you see this ln, you can think of it as log base e. And I believe we talked about e before. E is just, 2.71 or something like that. And it's just saying log base e of something. And so when you see ln, it's just called the natural log. That's all it means. Okay, so we're asked to expand this logarithm. Now we just want to refer to our rules up here. We're just going to apply those here. Okay, so I initially notice that we're multiplying. So let's get rid of that. Instead of saying that, let's say log base 8 of x plus what? Well, we do log base 8 of y squared. Sorry, that's kind of hard. Oh geez, my bad. Okay, hopefully that works. Okay, so since we're multiplying it on the inside, we can just add these two logarithms. Now we can go one step further, and since we have this exponent up here, we can bring that out front. So we can say log base 8 of x, plus, since we're raising this to the second power, we bring the 2 out front to be a coefficient. We say 2 times log base 8 of y. And that's just going to be our answer. Now here, I know it's sort of hard to see, we're dividing. And so since we're dividing, what are we doing? Well, we're going to be doing subtraction. So I'm going to separate this into log base, well actually we don't have a base, we have base 10. And we're going to say log of x to the 9th power minus log of y to the 4th power. And here, in both of these cases, we have these exponents. And so what can we do with those? Yeah, we can just move them out to the front. So we end up having 9 log of x minus 4 log of y. Something like that. Okay, let's move on to this one. Initially, what I'm going to do is I first see this exponent. So I'm actually just going to tackle this 3 and move that out. I'm going to say 3 times log base 2 of a to the 5th b squared. Now since we're multiplying this a to the fifth and b squared, we're just going to add. So we're going to say 3 log base 2 of a to the fifth. Some of this may be hard to see. Should probably just refer to what I'm saying out loud if you can't read my handwriting, because this, I don't know, this is tripping sometimes. I don't know. 3 times log base 2 of b squared. Now we still have these exponents, right? So we get rid of those by putting them out front. Now we already have exponents out front, right? Now what we're going to do here in that case is we're going to multiply 5 by 3. So we get 15 log base 2 of a plus 6 by 3 times 2 log base 2 of b. Okay. Hopefully that makes sense. Now we have ln. Now ln is what we referred to up here as the natural log, meaning it's log base e. But that shouldn't be too, this should not really change our answer that much in this case. Here, same thing as before. Initially, I just see this exponent, so I'm going to move that out front. Actually, oh jeez. Sorry, I just wanted to erase that because it got in the way of that. 4. So we're going to tackle this 2 by moving that out front and saying 2 times ln of x to the 4th over y to the 7th, right? By just moving that outside. And now, same thing as before, except opposite. And since we're dividing, we're going to subtract. So we're going to say 2 times ln of x to the 4th minus 2 times ln of y to the 7th. Sorry, that got kind of close. Hopefully you can just distinguish that line right there. Okay, now we have these exponents we have to deal with. Well, we put them out front. We multiply this 4 by this 2. We end up getting 8 ln x minus 7 times 2, 14 ln y. Okay. Hopefully you are getting a little bit more comfortable with these as we go on. Okay, this one I'm just going to assume this radical goes over the 7 too. But when we think of a radical, when we think of a square root in particular, well, what exponent are we raising that to? Well, whenever we're taking the square root of x, for example here, square root of x, that's just the same thing as saying x to the 1/2. Sorry, I don't know why this is so weird. So here, I'm just going to write this. Just disregard that radical. And I'm going to write to the 1/2 power. That's our exponent. Right? And so we can move that 1/2 out front. We can say 1/2 log base 5 of x to the 7th times y. Now we're multiplying, so I'm going to separate these. I'm going to say 1/2 log base 5 of x to the 7th plus 1/2 For some reason, this is like super weird. 1/2 log base 5 of y. Now the only thing we need to deal with here is this 7. Since we have it as an exponent, we can move it out front, meaning we can just say 7 over 1/2, right? We're just multiplying 7 by 1/2 log base 5 of x plus 1/2 log base 5 of y. Great. Perfect. Okay, now let's tackle this problem over here. Well, we have a radical saying the cube root of something. So if we had the square root right up here, this is just a 2, pretty much. If we're taking the square root and that equates to raising something to the 1/2 power, well, what do we think taking the cube root equates to? Well, it's just going to be the same thing as raising something to the 1/3 power. And so I would write it out, but it's going to get probably messed up by this. Just know that's to the 1/3 power. So I'm going to move that 1/3 out front by saying 1 over 3 times log base 4 of x squared y to the 15th. Yeah, that's weird. This is 15. Okay. Now we separate these, right? We're multiplying. I'm going to say 1/3. Hopefully you get the idea. It's easier to write on paper. 1/3 log base 4 of x squared plus 1/3 log base 4 of y to the 15th. Okay, well, we still have these exponents in here, so let's move those out by having them as coefficients. So we do 2 times 1/3, we're going to get 2/3 log base 4 of x plus, well, we have 15 times 1/3. That's going to give us 15 over 3, which is just the same thing as saying 5 log base 4 of y. And that should give you your answer. Okay, now we're condensing logarithms. So we're basically going in reverse. Well, if we have subtraction, that's the same thing as saying what? Yeah, division. And by the way, first thing we want to check, we have the same base. So we can sort of apply these rules. We have log base 9 of 35 over 7. Since it is subtraction that correlates to division. 35 divided by 7 is just 5, so I'm going to say log base 9 of 5. Boom. Here we have 3 log base 4 of 8 minus 5 log base 4 of 2. Now we have the same base, yeah, but we have different coefficients up front, and we have different numbers in here. We have an 8 here and then 2 here. So this is sort of where becoming familiar with logarithms, after you see this once or twice or 3 times, you'll be able to catch on. But in this case, we want to have the same argument, right? we want to have the same argument. And so the way we do that is by, instead of saying 8, how do I make it into a 2? Well, instead of saying 8, I can just say 2 to the third, right? And now that I have that 2 to the third, I can take that exponent and move it out front, which is kind of clever, right? And so we can say 9 based off 3 times 3 log base 4 of 2 minus 5 log base 4 of 2. Now, what we want to do here is, since we have the same base, right? We have the same subscript, we have the same argument, we can just subtract. So we do 9 minus 5 is 4 log base 4 of 2. That gives us our answer. Right, we can just subtract these because, this entire part is the same amongst both. So we can just translate that. If we have 9x minus 5x, that gives us 4x. And so that's pretty much the same thing we're doing here. Okay. Let's move down to this one. Well, we have 1/2 log base 3 of 81. Well, that 1/2 is out front. It's a coefficient. So what we can do is we can go in reverse. Remember how before we, moved this 1/2 out front? Well, let's just do the opposite. Let's move this to be an exponent, right? And then we'd get log base 3. Oh, Lord. You get it. That's a 3. Log base 3 of 81 to the 1/2 power. Well, 81 to the 1/2 power is the same thing as saying the square root of 81. So this is basically the same thing as saying log base 3 of the square root of 81 is 9. Now let's go back to the very beginning. What is this saying? This is saying 3 to some power, just going to say x, equals, this, just for notation's sake, is not equal to, I'm going to say, this is log base 3 of 9 translates to 3 to the x power equals 9. So what is this x? 3 to what power equals 9? X is just going to be equal to 2. So this entire thing just equates to 2. That's pretty simple. Okay, so for 4 here, we notice that we have this log base 3 of x, this log base 3 of x. So what we want to do is we want to combine those. It's just like what we did up here with this log base 4 of 2. So how we do that? Well, we're just going to add 7 and 4. We get 11. And I'm just going to write these just so I don't get them mixed up with the log base 3 of x, right? And now we have this 2 log 3 of y. Okay, so we have this same base, right? We have this b value of 3. And now what we want to do is we have these different, right? We have these different coefficients, my bad, out front. This 11 and this 2. And by the way, this x and this y are different, of course. And so that's why we can't combine those. So how are we going to make this something on the outside? How are we going to get rid of this coefficient? Well, we're going to do that by taking this and raising x to that power. Same thing with this 2. So that this will become log base 3 of x to the 11th power equals, or sorry, my bad, not equals, minus log base 3 of y squared. And now we have this subtraction sign, and so the way we get rid of that is this log base 3 of x to the 11th. Since we're subtracting, we divide by y squared. Hopefully you can see that. 11. Okay, so that's how we do that. Now we have something over here for 5 that looks pretty similar, right? It looks similar. I think it's reversed in order, and now we have this x to the 3rd. But here we're gonna pretty much do the same thing here in the beginning. Our first step is gonna be the same. We have this, we see both of these terms have log base 4 of x. So how do we, simplify that? How do we combine those two terms? Well, since we have a like term, we can just do 7 minus 2, 5, log base 4 of x. Now we have, from here we still have this plus 4 log x to the 3rd. The log base 4 x to the 3rd. That's an x. So actually what I see here is initially my first instinct was going to be to take this 4 and put that up. But I see that this logarithm over here has an x for its argument. So what we want to do here is just have an x for our argument here. So the way we do that is by taking this 3 and placing it out front. So I'm just going to, if you're fine with me, just saying instead of x to the 3rd, I'm going to move that out front and do 3 times 4, and now we have 12. And from here, hopefully you can see it's pretty much the same deal. 5 plus 12 is 17. 17 log base 4 of x. Boom. Okay, here. This may look super complicated, right? We see this over 2. I don't know, it just looks weird. Well, this over 2 is actually the same thing as this 1/2, which is the same thing as raising our argument to 1/2. We're actually going to get to that. First, we should just tackle this numerator. Sorry, I got a little bit ahead of myself. So here for this numerator, we're subtracting. And so since we're subtracting, what does that mean we're doing to our arguments? By the way, arguments just whatever's on the inside. Well, we're doing 45 divided by 5, which I hope you're just good with me saying is 9. Oh, sorry, log base 6 of 9. And I'm going to put this, like we talked about, this 1/2 out front. Okay, so we have this log, or 1/2 log base 6 of 9 plus log base 6 of 12. Now what I'm going to do here is take this coefficient, this 1/2, and raise 9 to that power. Sorry. 9 to the 1/2 power, which is the same thing as saying the square root of 9, which is the same thing as saying 3. So I'm just going to raise this and say 3. Plus log base 6 of Now, here we have addition. We have the same base. So what I'm going to do here is just say log base 6 of 3 times 12, which is 36. Now, what do we learn this is in terms of exponents? Well, this is 6 to some power x equals 36, right? If we're just rewriting this out. Well, that x value is actually going to turn out to be what? My bad. It's going to turn out to be 2. 6 squared equals 36. So this is actually going to be our answer, 2. And basically what that means is, you see this, all this, so messy. Well, that's equivalent to 2, and this is a much simpler way of writing it out. So simplifying and condensing all of these logarithms into something as simple as this, that's pretty satisfying. Okay, so we're going to review real quick. I'm just going to go rapid fire. Here we have log base 8 of 32. That's the same thing as saying 8 to the x power equals 32. I'm going to break this down into, well, I know both of these are, they're multiples of 2. I know 2 to the third is 8, and 2 to the fifth is 32. So if I break 8 down into 2, I'm going to get 8 to the 1/3 equals 2. And then I'm going to get 2 to the fifth equals 32. I'm going to take these two exponents, multiply them. I'm basically going to get 8 to the 5/3 equals 32, meaning our answer is 5/3. Basically, this is the same premise. You can think about breaking it down into the simplest form. Hopefully, you feel somewhat comfortable once you get to this state, because we kind of talked about exponents and exponent rules before. But if you don't, certainly email. I can try to help you. Go to Mr. Whitaker or Tutoring Center, anything like that. Here we have negative 27 to some power equals 1/81. And actually, this is important to have parentheses there because this negative is part of that. So how do I get from, I'm going to disregard all the negatives, all the fractions. How do I get from 27 to 81? I think we did something like this before, but we do 27 to the 1/3 power equals 3, right? We get it, we break it down into 3, and then we build that back up. If we see before, 3 to the 4th power, my bad. 4th power equals 81. Now I'm just going to multiply these two. 27 to the 4/3 power equals 81. Now we have, we have 1/81. So if we have a negative exponent instead, if we have 27 to the negative 4/3 power, we're going to get 1/81. And now, even this negative 27 actually is not even going to matter, because let's actually start from the beginning. If we have negative 27 to the 1/3 power, we get negative 3. The cube root of negative 27 is negative 3, meaning negative 3 times negative 3 times negative 3 is negative 27. because negative 3 times negative 3 is 9. 9 times negative 3 is 27. And now once we have negative 3 to the 4th power, well, anything to the even power is going to be positive. So this negative sign isn't even going to contribute. Sorry, I don't know what just happened. So our answer is just going to be our exponent, which we found to be negative 4/3. See that right there. Okay, we're asked to condense here. First thing I'm going to do is, take this. First thing that jumps out to me is this 1/3, or this dividing by 3 is the same thing as saying 1/3, which is the same thing as saying ln of z to the 1/3 power, right? And now we have 3 ln x. I'm actually gonna, I'm gonna do all these right now. Since we have this exponent out front, this coefficient out front, we can turn it into an exponent and say ln of x to the 3rd minus, same thing with this, move that y to an exponent, ln of y to the 5th plus what we just did, ln of z to the 1/3. Now here we're subtracting, so we're going to be dividing. We're going to have ln of x to the 3rd over y to the 5th. But now we're multiplying this z to the 1/3 power, so we can write that on the numerator. And I hope you're fine with me doing those 2 steps in one. It will get the same answer. If you do it out by yourself, you should get the same answer. I'm just combining those 2 steps. Okay. Okay. Here we're asked to expand log base 3 of 5 times the cube root of xy squared. First thing we want to do is we have this 5 and it sort of feels weird, right? We can't do anything with this cube root yet until this 5 is away. So first thing I'm going to do is, since we're multiplying, I'm going to get rid of that 5 by doing log base 3 of 5 plus log base 3 of the cube root, which actually I'm going to rewrite as xy squared to the 1/3 power. And this works because we're adding, we have the same base, and so since we're adding, we would multiply here. So we're just going in reverse. And now what I'm going to do is, we still have that log base 3 of 5. Sorry, that looks weird. And we do plus. Well, I'm going to first bring out this 1/3 to the front. Say 1/3 times log base 3 of xy squared. And we have log base 3, 5 plus. Now here I'm going to separate this x and y squared, and I'm going to do that by just adding, right? We're going to separate it and add since it is multiplication. So I'm going to say log base 3 of x, then plus. And remember that 1/3, because that 1/3 translates to both of these terms, right? We have 1/3 log base 3 of y squared. I'm sorry if my handwriting is bad. Now I have this square, bring that out front. we're going to end up getting log base 3 of 5 plus, I'm just going to rewrite this as log base 5 of x over 3 plus 2 times 1/3 is just 2/3. I'm going to write that as log, or 2 log base 3 of y over 3. And that's our answer. If you guys have any questions on some of the processes we discussed in this video, just go to one of your teachers, come to the tutoring center, come to me, ask your peers, consult the internet. There's a multitude of resources you have at your disposal, and just use them. Yeah, I hope this helps. Thank you.